Hi, I'm Carl, and I'll guide you through different types of IDS systems, detection mechanisms, and general IDS evasion techniques. Since the dawn of the internet, admins have tried to protect the networks against malicious users, malware, hackers, kiddies, and government instances who scan their networks for open ports, services, and device types, trying to access them with an arsenal of common tools. To get an overview of these threats, IDS has been developed. Intrusion detection is the unrelenting active attempts in discovering or detecting the presence of intrusive activities. It refers to all processes used in discovering unauthorized uses of network or computer devices through special designed software detecting unusual or abnormal activity. There are different types of intrusion detection systems. Most are installed on a networking device, others on a networking client. Physical intrusion detections will not be covered in this video. The network IDS is installed using a span port or in tap mode, almost invisible in the network. All network traffic that passes the IDS sensor in permissions mode is analyzed using pattern matching type algorithms in search of certain TCP flags, strings, data headers, etc. Whenever an intrusion is detected, the system logs the information about the attacking system, such as operating system fingerprints, IP addresses, MAC addresses, attacking tools, and protocols used. An intrusion prevention system is able to act upon any detected intrusion. These systems are capable of dropping, silently dropping, rejecting, logging, pausing, and alerting malicious activities. Host-based intrusion detection systems are installed on host itself and are usually implemented as a standalone software solution such as OSEC. Some are installed independently while others have a central server, with each host acting as an agent reporting all local behavior. Most of these host intrusion detection systems focus on a certain OS and vulnerabilities for that operating system. Spectre is an exception as it supports up to 14 different operating systems. Some install a honeypot to deflect attacks and gain more information about the attack while alerting the user of intrusions or attacks, and keeping the attacker occupied. The downside for having a host intrusion detection system installed on your computer is it uses a lot of system resources and is a huge drag on system performance. Each intrusion detection system type has its own implementation of searching for intrusions. In general, the following three are used in all modern IDS installations. The first is signature-based detection. This manner of intrusion detection is helpful to detect common threats on well-maintained systems with up-to-date signature databases. This can only ever be as good as the extent of the signature database, where every known attack signature is to determine if an activity seems to behave suspicious or not. The problem is that the system has to be updated regularly and can't detect 0 days. The more advanced the signature database is, the higher the CPU load for the system charged with analyzing each signature. This means an IDS has a maximum number of signatures it can analyze. High traffic load causes the IDS to drop activities as it cannot maintain the high load. Besides this, it is easy to fool a signature-based system by altering attack manners. A new detection mechanism was developed as an additive to common signature-based detection, which could be evaded easily. A database of unharmful innocuous network traffic and system processes is built for anomaly detection. If an analyzed activity does not match a database query, it is processed as an intrusion, and thus a malicious activity. The main problem with this is roughly the same as with signature-based detection. One cannot define all normal activity. Because of that, false flags may arise and many activities may not be recognized. It is a good protection against unadvanced attacks. It does require more resources than signature-based detection. Protocol anomaly detection is the latest detection technology which seems to be the most effective. It is based on all requests for comments which describe all protocols and aspects of TCP. This yields a much smaller database as not every malicious activity has to be defined and the RFCs are well defined. This does not guarantee that all types of malicious activities are found, as there are design flaws which may be exploited. Now the implementation of detection methods is known, it should be easy to understand the following attack vectors. This line contains a list of attack vectors who try to use all available IDS resources. In case the IDS writes its log files to a remote location, DOSing an IDS is easy by DOSing those log servers. The storing is purposed to log about intrusions. bombarding the IDS with their volumetric DOS or occupying the IDS with difficult-to-analyze network traffic results in the IDS running out of resources to analyze regular activity. Session splicing is sending data in as much packets possible by playing with the MTU value of the packets. As a large stream of small packets may cause the IDS to drop frames to balance the overload, malicious activities may not be detected. Also, the reassembly of streams could fail under the overload of data to process. To enhance this attack, a random delay between network packets may be used. This boosts the difficulty to reassemble a network stream. The generation of false positives is an evasion technique which creates a huge amount of alerts, whereby the detection of real intrusions gets lost in the vast amounts of alerts. These evasion techniques exploit the inability to decipher the content of messages sent to hosts on the network. Obfuscation is the obscuring of intended meaning in communication, making the message confusing, willfully ambiguous, or harder to understand. It misuses the IDS's ability to recognize certain strings. An IDS can be evaded by obfuscating or encoding the attack payload in a way that the target computer will reverse the message, but the IDS will not. In this way, an attacker can exploit the end host without alerting the intrusion detection system. Encrypted data cannot be read by a network intrusion detection system since it does not store any certificates and can't follow encrypted channels, such as SSH. A host intrusion detection system would be capable of doing this. The Unicode evasion attack uses different Unicode encoding for the same characters. By encoding a string several times without affecting the contained information, signature-based detection can be avoided. Polymorphic shellcode or ASCII evasion techniques are possible by concealing shellcode as an ordinary string. Signature-based detection will not detect this as an attack. The same goes for ASCII shellcode, as some pattern matching databases do not contain malicious plaintext ASCII strings. An advanced approach is sending a decryption program with your encrypted data. By using an integer buffer overflow, the data could be decrypted on a host by changing the memory pointer to the decryption program, loading the encrypted data, causing the encrypted payload to execute. A fragmentation attack tries to exploit the reassembly timeout of the intrusion detection system. By sending packets with a higher delay than the IDS reassembly timeout, some packets are not analyzed. This causes the IDS to not have a complete reassembly of all data and failing in applying a proper detection. If the reassembly timeout of the IDS is higher than that of the victim host, network traffic with false IP checksums may be used. A time-to-live based attack sends packets with different time-to-live values, whereof some have a time-to-live of 1. This causes the IDS to receive more packets than the victim host, as packets with TTL1 will be dropped. Router is installed behind the IDS. The intrusion detection system interprets different data after reassembly compared with the victim host. An attacker can exploit conditions where an end system rejects packets, while the IDS does not reject them. The attacker literally injects packets into the intrusion detection system, while no other devices on the network accept the packets. If an attacker tries to set up a TCP/IP connection with a host, he may send packets with the TCP reset flag set, but with a false CRC. The IDS will suppose the connection is terminated while the host will drop the packet because of the false CRC. The IDS will no longer follow the TCP socket session and an attacker is able to evade the IDS. The post and pre-connection SYN attack tries to confuse the intrusion detection system with bogus SYN packets. SYN packets sent before the TCP three-way handshake confuse the IDS, causing it to start with a bad sequence number and failing to follow the session. SYN packets sent after the three-way handshake with bad CRC will try to resynchronize the IDS with a bad number. The result is the same as with a post-connection SYN attack.